Hi. I chose my science experiment about rising oceans, which is a subtopic of global warming, but because global warming is, huge, I chose rising oceans. How is global warming affecting sea levels is my main question, and my hypothesis is if global warming increases in temperature, then the glaciers will melt faster than evaporation can decrease ocean levels. Now, before I get into my experiment and my process of it, I did some research just explaining global warming and how it will affect us and the general important topics. Okay, so if we go in, what is global warming? Global warming is pretty much an effect of greenhouse effects, which pretty much causes the Earth to have a blanket over top of each other. What happens is that the greenhouse effect is an action of our atmosphere trapping heat between the Earth and the stratosphere, which is a level in the atmosphere, and certain gases remain semi-permanent. So it pretty much makes it really hard for these gases to escape, and these gases include water vapor, nitrous oxide, methane, and carbon dioxide. And those are caused by things such as creation of vehicles, burning fossil fuels, agriculture, forestation, landfills, manufacturing plants, domestic livestock, and cows, and things such as nature causes that could be affecting global warming is natural gases, sun, and volcanic activity. But nature effects are short-term, meaning they only last in our atmosphere for a short period of time. So the main cause is really from mankind. Nature is it's not really affecting anything. An important question is, how will it affect us? So how is global warming going to affect, the world? Extreme precipitation and harsher storm season, example hurricanes. So pretty much any type of storm you can think of, rain, heat waves, it's all going to become more extreme. Agriculture problems, longer the spring, which means water supplies will struggle. So it's pretty much what I'm saying. Heat waves will become longer, or they'll be shorter, but they'll go on for a long period of time. Sea levels rising, saltwater could contaminate fresh water, so as they rise, it can contaminate. Glaciers, ice sheets, not icebergs. You see, icebergs do not affect sea levels. They're already counted in the sea level because icebergs are already submerged in the water. Glaciers are above land. They affect things. So once the heat rises in the universe or the world, it falls into the water and then it starts to melt, which rises sea levels. So yeah, icebergs that are already previously in the water do not affect anything. Anyway, so glaciers, ice sheets, which are melting, and rising temperature of oceans affecting sea level. Weather will be more extreme, longer, more frequent heat waves worldwide. And that's pretty much how it's going to affect us. So how are sea levels measured? Sea levels are measured by gauges that measure the height of the water. Satellites use radars that bounce off the surface of the ocean, which determine the height of the sea. So that's pretty much how it's measured. It's just a quick satellite just bouncing off the surface of the water, and then the gauges measure the height. And that's pretty much the basics of what you need to know for my project. And now we're on to my experiment. Okay, so my experiment. I did one big experiment with using glaciers, as you can tell, because it was above the water. It wasn't directly in the water, and because I didn't decide to use icebergs since they do not affect the sea levels. I also colored the water a little using methane blue, which is pretty much just a dye for the water. It's completely organic, just so you guys can see where the level of the water is. My materials that I used was a clear bin, salt water, around 25 liters, 2 thermometers, a phone for taking pictures and video, a strainer to hold ice, heat source, 1 ice block, which is 6 cups, which you can see by the longer one, and 2 small ice blocks that were 2 cups of water, a ruler, and a Sharpie. Pretty much what I was doing is after I set up my entire experiment, I started my camera to record the experiment, turned the heat dish, and waited 21 hours for the ice to melt. 21 hours. You'll see that in my graphs. Waited for that to melt, and each 30 minutes we would measure the air temperature, the water temperature, and the water level. As you can tell, we started the experiment at 5:03 p.m. and it was this big. This was about midway, so it was 12:03 a.m., which was halfway, and then it ended at 2:30 p.m. and all ice was melted. So these are my graphs of the air temperature. As you can tell, we graphed it off from the experiment. This was the water temperature. How the water rises in how water level rises in global warming experiment. It's the same as the others, and this was our table that we used during the experiment to just measure each and every 30 minutes. And the average of air temperature was 18 degrees Celsius. The average of water temperature was 15.63 degrees Celsius. And the average water level, so each time, every 30 minutes, the average water level went up 0.607. And the water in total, so from the beginning to the end, the total water went up 0.9. So for the experiment, to compare our experiment to what's happening around the world, so this was our graph. As you can see, it started going up and then it decreased when we slept because we didn't want to stay up all night measuring this. So we turned everything off to let it kind of counterbalance, like in the world, it kind of cools down at night, right? So we decided to turn everything off and let it go, and then we turned it back on once we got up in the morning. To compare NASA's to ours, it wasn't an exact replica considering its air temperature because we influenced it, so it's not an exact measurement. We were God. We controlled it. So we can't exactly, use this as proper data to compare it. So the changes in water temperature, NASA didn't necessarily, there wasn't an exact graph for comparing the water temperature, but it does have a similar to global temperature. As you can tell, this is the topic of global land ocean. So it kind of varies between the air temperature and the ocean temperature. And as you can tell, they both kind of have a slow start. They dip a little, and then they have a sudden ping of heat wave, and then goes down and kind of increases slowly as they go up. For our water level rising in global temperature, once again, we were asleep, so all of these did go down while we were asleep, considering everything was turned off. And then to compare NASA's to ours started off very slowly, and then once the iceberg glacier started to slow down, it kind of leveled out considering there wasn't much left of it. So how we compared ours to NASA's was just saying they both increased as the water level was rising. So once again, it's not going to be an exact replica because real life glaciers are absolutely ginormous. And then to compare NASA's to ours started off very slowly, and then once the iceberg glacier started to slow down, it kind of leveled out considering there wasn't much left of it. They both increased as the water level was rising. So once again, it's not going to be an exact replica because real life glaciers are absolutely ginormous. Then we concluded that our comparison between NASA's and ours was that at the beginning, it could withstand the temperature. So it could withstand the rising temperature for a bit longer, but as the temperature increased, it started becoming higher and higher to a point where it has a current flow. So obviously the first two blocks that finished melting were these two small ones. And we concluded with this experiment that it's better to have multiple large blocks of ice than it is to have many small ones, because then global warming will accelerate faster than it would with just a couple very big, large pieces of ice. Give you guys an example of how global warming will affect, or how sea levels will affect the world. This is what North America will look like after all the ice in the world is melted. As you can tell, the blue line outside of the green, which represents the land, all of this is how far the sea levels will rise. So for an example, New York will be completely underwater. Like, say goodbye to your New York, guys, because it's leaving. How high will sea levels rise once all the ice is melted? Assuming that all the ice in the world, from Antarctica, Greenland, and all the glaciers and ice sheets, then the sea levels could rise between 60 to 70 meters, which is quite a fair bit. To give you an aspect of what that would look like, Parksville, it wouldn't let me go above 30 meters. So this is how high Parksville sea levels will rise, at 30 meters. And then measuring how high it went from 10, 20 to 30 meters, I made an assumption of how high it will rise once it hits about 70. And our school, which is right here, will be completely underwater. So say goodbye to Bolinas, because in about 5,000 years, when all the ice is melted, it's going. It's leaving. It's not here anymore. The experiment hypothesis was proven correct. The heat source was increased at 9:30 p.m. to medium high from low. That was for the outside temperature to balance off the dropping temperature outside. And then as the temperature warmed, the meltage rate increased because the ruler jumped from 12.1 centimeters from a consistent 11.9 and stayed at 12.1 until the water level dropped at midnight. And that is due to evaporation. So the higher the heat becomes, the faster evaporation will accelerate, but as well as the melting rate will accelerate as well. In our experiment, we were trying to recreate the cycle of global warming. And a way we could have improved making that was by using saran wrap instead of this metal container that was holding the ice. Instead of using the metal strainer, we could have used saran wrap and then poke holes into the bottom of it and then close the lid to recreate the stratosphere. And that would have created a more natural and the unnatural environment effect, so we could have received better results. Final step of this experiment is the next step of this project is to find a way to slow down or eliminate global warming and the greenhouse effect. Except more research needs to be done before I or anyone else could do that. Some theorists still believe that reducing emissions won't solve the increased temperature since it has passed the point of no return. So there is multiple different debates about we can't eliminate anymore, it's not going to exceed anything, while others say if we eliminate it, it will solve everything. So there's still too many opinions about that. So making a project would be hard, but once all of that is solved and they get the scientists get a more general idea of how to solve it, The next step would to have a new project with the question being how to solve global warming despite the differences in opinion. So I can make multiple different projects, so the three main ideas that they have to solve global warming. I would create 3 experiments using those ideas and see which one is more effective. Thanks for listening to my project. I know it was a little long, probably eerie, but thanks for listening. Thanks for watching. Hope you enjoyed. I know I definitely did, staying up till 12:30, 21 hours of doing this experiment, but it was fun. Normal day in this house. So thanks for watching.